Welcome dear viewers to the video on topic residual solvent limits. In this video we are going to learn regarding the calculations for the specification limits for residual solvents. Residual solvents are also called as organic volatile impurities sometimes, but generally these are referred as residual solvents. And if you are using the solvents like ethanol, acetone, methanol and some others in the formulation or in the drug synthesis, then these are required to be tested in the drug substance, or it may be in the excipient or in the drug product. And the limits are derived considering the principles given in the ICH Q3C guideline and the USP General Chapter 467. So let's start the video with the options for calculation. Whenever you come across the specifications for residual solvents, that time always remember that there are two options for the calculation of the residual solvent limits. There are three main classes of the residual solvents based on the toxicity: class 1, class 2 and class 3. Class 1 are toxic, class 2 are required to be limited, and class 3 have the higher permitted daily exposure limit, that is PDE. But all the residual solvents or volatile organic impurities are required to be considered as the impurities, and these are toxic in nature. Their use should be restricted, their use should be reduced. Only if it is required, then these are to be used. So now come to the two approaches for the calculation of the residual solvent limits. First is option 1, that is fixed concentration ppm, and second is the total daily exposure, that is mg per day. Now consider a product you are making with some dry granulation process. You can consider it as uncoated tablet. So you don't need to test the residual solvents because you are not using any solvent in the manufacturing process. So is it true? So as per my understanding, it is not true. You are not going to test, that is true, but you need to check whether all the excipients complies to the limits. If all the excipients complies to the limits and you are not going to use any solvent in the process, then there is no requirement of testing and there is no requirement of the residual solvent specification. You can provide justification that you are not using any solvent in the manufacturing and all the excipients and drug substance complies with the limits for the residual solvents, and those limits are set by the suppliers. So that only part you have to do. If you are going to use the solvent, then compulsory testing is required. Now once again we will come to option 1 and 2. Option 1 is called as or known as fixed concentration or ppm option. When the daily dose of the product is less than or equal to 10 gram or your dose is not known, then option 1 can be used. Formula for calculation of the ppm level of the residual solvent is ppm is equal to 1000 into PDE divided by 10. Why 10? Because 10 gram dose is considered as maximum dose for the option 1. Now 1000 is the factor. PD is mg per day. It is the unit of PDE, that is permitted daily exposure, and dose is given in the gram per day. Now take the example of acetone or ethanol. The ppm is 5000 ppm considering the option 1 limit. Example, acetonitrile PD is 4.1 gram per day. So 4.1 into 1000 divided by 10, it will become 410 ppm. The main understanding behind option 1 is that each of the ingredient along with the excipient drug substance meet or must meet the ppm limit individually. That means all the excipients drug substances are not containing the acetonitrile beyond the 410 ppm. Then you can directly use option 1 and you can use the excipients in any proportion. You will meet the limit of acetonitrile, that is 410 ppm. So the information is based on the ICH guideline Q3C and the USP chapter 467. Now the example option 1, excipients are containing the acetonitrile. Example, excipient A contains 350 ppm. Your limit is 410 ppm. So it is acceptable. But if the excipient B contains more than 410 ppm, like 450 ppm, limit is 410 ppm, it is not acceptable. So then you need to go for the option 2. Understand and remember that option 1 is fixed concentration ppm. Directly ppm level PDs are given. Directly you can use those PDs or you can convert these PDs into the ppm and you can give the specification. For example, the specification for methanol will be 3000 ppm, acetone, ethanol, IPA, that is propanol or isopropyl alcohol, all these have the 5000 ppm level. If any of the excipient is not meeting the limit, then you need to go to the option 2, and option 2 is the total daily exposure mg per kg. Now when you are going to use the option 2 with total daily exposure, that is mg per day, if your daily dose is about 10 gram and if some components exceed the option 1 ppm limits, then coming to the formula for total daily exposure in mg, summation of the ppm into component amount divided by 1000. Component amount is given in the gram. So add all the excipients, provide their limits, do the summation and check whether your product is complying or not. Key point is to add exposure from all ingredients and compare with the PD. For example, the acetonitrile PD is 410, and if you are not meeting or summation of the components is not meeting, that time you need to test the formulation. Example 1, product complies the option 2. This is the example where product is not meeting option 1 but it is complying to the option 2. It is a hypothetical example I have taken. Drug substance 0.3 gram, excipient 1 0.9 gram, excipient 2 3.8 gram. Total exposure in mg per day, it is 3.64. That is 0.3 into 800 ppm, it will become 0.24 mg in considering the residual solvent. Then excipient 2 it will become 0.36, excipient 2 it will become 3.04, and total it will become 3.64 mg per day. So if you consider the total daily dose of 5 gram, it will become 728 ppm. But the total mg, it is 3.64 mg, and the limit, that is PD for acetonitrile, is 4.1 mg per day. So the product is acceptable. Now second example I can say, it is where the product is failing. Now drug substance is with 0.3 gram per day exposure, excipient 1 is with 0.9 gram, excipient 2 is 3.8 gram. Total exposure considering the ppm levels is coming 5.08 mg per day. You calculate the mg per day from the drug substance 0.3 gram into the limit of acetonitrile 800 ppm. It will become 0.24 mg. 0.9 into 2000 ppm, it will become 1.80 mg. Then 3.8 gram into 800 ppm, it will become 3.04 mg. Do the summation of all, it is coming 5.08 mg per day, that is 1016 ppm. And what is the PD? PD is 4.1 mg per day. So your exposure is more. That's why the product is failing the option 2. Now what to do if your option 1 is failing, option 2 is also failing? Then it will require reformulation of the product to get the product within limits for residual solvent, and you need to provide the justification. Comparison of the two approaches. Option 1 ppm, it is simple, conservative, and it is suitable for the products with less than 10 gram dose or dose is unknown. Then option 2, that is mg per kg, mg per day, it was my mistake. Option 2 is considering the mg per day. So it is flexible, real world based, and in this you can directly do the summation of all the exposures based on the limits, and it is needed when the total daily dose is more than 10 gram, or if any of the individual material limit exceeds the PD. In summary, ICH Q3C and USP chapter provides the PDE based safety limits. You can go for option 1 or 2 depending on the dose and the composition. And if you find that the PD is exceeding, the product is failing to meet the criteria given in the ICH guideline or USP chapter, then you need to reformulate the product or reduce the solvent levels and provide the risk benefit justification. Many of the times in process checks will help you to reduce these toxic solvent to the safe level. Drying can help to remove. Sometimes because of the supplier change or because of the selection of the suitable vendor with who can provide you the excipients or drug substances with reduced limits can help. These are some of the ways to have the residual solvents within limit. I hope this video will help you to understand more about the terminologies and more about the calculation part. If you have any doubt, you can mail me or you can comment. I will try to solve your query. But remember that if you are reading any guideline or USP chapter, thoroughly you should read it. You should take some examples and calculate the limits. Then only you will remember whenever it is required. Thank you for watching the video. Let's meet soon with such kind of informative video.